So thanks for the intro. My name is Nick Black. I am one of the founders and the Chief Product Officer at CloudMade. And I'm going to talk over the next 25 minutes about how CloudMade is using machine learning to deliver very, very personalized experiences into the connected car. So quick intro to CloudMade. There are three key parts of our business. The first is a set of software solutions which are responsible for machine learning. We have a unique architecture, which I'm going to jump into. We have a professional services business where we work with our customers, OEMs and Tier 1s, to build some of the experiences that you've seen announced earlier on this year from our first OEM customers. And we have a partner ecosystem of different partners, whether they are content providers, other software companies that we typically build projects with. My two co-founders, Jim Brown and Juha Christensen at CloudMade, they've spent most of their career building mobile operating systems. So Juha was actually one of the founders of Symbian. He was then instrumental in Trolltech, who made Qt. Jim worked with him in a number of those places. So the heritage of CloudMade is very much in operating systems. And we think about what we're doing in the car space as being like building an operating system. But this is not an AutoSAR, it's not a Linux, it's not something at that level. It's a layer that sits above the operating system and provides personalization to every different aspect of the car. Our mission at CloudMade is to make the car the most personal experience a driver ever encounters. We want people to get into their cars and feel a very strong bond, an emotional bond between what they see on the screen, what they feel from the seats, the atmosphere that the lighting creates around them. We want them to feel a very, very close tie between their car and their personality, because we're spending hours in our day in our cars, and cars are really the best environment that exists today for this kind of deep personalization. So at CloudMade, we're working on doing this in three different domains. The first is in what we call the ride, the different chassis components of the car, how the suspension reacts when it knows you're going to drive in a particular way. We're doing it in the cabin. We're building full-scale prototypes with some of the biggest providers of cabin materials, which are showing how the whole cabin, from the seating to the lighting to the HVAC systems, how they can act and behave to give you an experience that fits you, what you're doing in your day, the passengers you have in your car. And finally, we do a lot in the HMI layer, so how all of the different screens and speakers and interactions that go on in the car can become personalized to you, the driver. So I'm going to talk today about some of the challenges that we face whilst doing this and how CloudMade works with our OEM customers to help overcome those challenges. So any of you who've ever climbed up a mountain like this one will know that one of the frustrating things of being a mountain climber is the false peaks that you find along the way. You're standing at the bottom and you think you have a straight line of sight up to the top, but you don't. All you can see is the next peak. So clearly, one of the first problems that we faced at CloudMade as we started architecting this system about 4 or 5 years ago is that a connected car is not a connected car. It's a sometimes connected car, because there's no such thing as ubiquitous, always-on internet connection when it comes to the car, especially as you go into those lower-level components like seating and chassis controls. The kind of reliability you get from an internet connection into a connected car is just not good enough. But because we didn't want to be outdone by the false peaks that we see, we also tried to focus on the bigger picture in the industry, which is shifting business models. And that if we are building for 7-year development cycles like we have in this industry, the problems that we solve now are not the problems that are going to be around in 7 years' time. So we also address some of the big issues that come from changing business models. I'm talking about things like Uber and Lyft and the coming of Google and Apple into the space. On the way, we've had to deal with the fact that many interfaces in the car, the traditional way you interact with a car, has been designed for a disconnected world, a world with a very low bandwidth of information, and that's something that's changing very rapidly. We, of course, have to deal with the unique electronics architectures that every different car has. So even within one manufacturer and one vehicle line, there can be different electronics architectures, which pose some very specific challenges for doing what we do. And of course, there are exceptionally high consumer expectations when it comes to cars. You know, where else do you get products with 10-year guarantees that you can drive to the Arctic Circle and the Sahara in the same day and expect them to function in exactly the same way? People place exceptionally high expectations on their cars. And as a software provider to OEMs and Tier 1s, we need to be able to perform to those expectations. So I'm going to take you on a little journey through this today. So problem one, the sometimes connected car. The way we address this is by creating a distributed environment for machine learning. And it works like this. Down in the car, CloudMade has components that are observing data from the CAN bus and other buses. That data is then periodically sent along the telematics connection, typically through the TCU, up to the cloud. In the cloud, the observations are aggregated together. They're run through a number of different context-specific machine learning modules where a model is created specific to the problem being solved and the user, and that model is then synced down into the car where it's used to assist the driver. So for example, over here in the learning, if we are trying to solve a problem like predicting the next destination somebody is going to or predicting a route they're driving on, we might use a Bayesian network. The object which is synced down from the cloud into the car is just the Bayesian network for me, so it's very, very, very small. So in doing this, we're able to leverage the best of both worlds. We're able to leverage the ability of the cloud to learn, the vast computational power that you can put together in the cloud. We're able to suck in data sources like historic traffic, weather. We're able to connect to social networks. We're able to get hold of all of the data that you typically need to do machine learning up in the cloud. But we also are able to satisfy the key requirements that you get in the car, which is that the car systems have to be able to operate asynchronously. They have to be able to operate offline. So that red circle in the middle, that can be cut at any point, and both processes keep on going. The car keeps on predicting. It keeps on delivering personalization. We customize the frequency with which the data is both uploaded into the cloud and then downloaded back into the car, depending on the use case, but depending on cost constraints, depending on the current network saturation of the TCU. It's highly, highly configurable. One very important factor is that that cloud is not CloudMade's cloud. We're not a software as a service company. We're a software as a product company. We provide our software product to our customers, OEMs. They install that in their cloud. And their cloud is typically their clouds. They may have one in Europe. They may have one in specific countries in Europe, one here, one in China, and so on. That's a really key part of what we do, so the OEM can retain in control of the data. So what it looks like for CloudMade is this. We enable a lot of different use cases from one driver profile. Now, this is key to what we're doing, which is quite different from other approaches to learning. Over the next years, machine learning is going to be involved in all kinds of applications. It's going to become very commonplace. What CloudMade has been focused on is building a framework to allow the things that are learned in the car to be accessible from all other car systems. So the navigation system, for example, may learn that you tend to leave your house at this particular time and you tend to drive for this long. That is not only available to the navigation system, that's also available to the seating systems. So the seating system can configure itself to make sure it keeps you comfortable for your journey, whether that's a 5-minute trip to your kid's school or whether it's a 5-hour road trip to somewhere. And you can only do this by creating a system which makes the learning accessible across the rest of the car. I mentioned the heritage of building operating systems in CloudMade. This really comes from operating system thinking, building a lot of reusable components. The next problem that we help solve is that interfaces in the car were created for a disconnected world. You know, the paradigms that exist in the car, the idea of the way that the driver goes in and pulls information to them, that was created when there was no connectivity in the car, when there was really a very simple number of things that had to be done in the car, which involved using car systems, which were very basic. There was no adaptive cruise control. And when the most complex thing you were doing was changing the channel on the radio. And things, of course, have changed hugely, but the underlying technology behind the user experience has not changed up until now. So what CloudMade has built is a range of different projects that address this. The first is something we call the adaptive UI. And this comes from using a collection of our different learning modules, which you see down at the bottom. We call these inference engines. These are modules that learn in the cloud a specific thing or set of things about the driver and then make predictions in the car to help personalize the experience. The adaptive UI are all of these different components that enable the UI to understand the driver, their intentions, their context, what they're going to do next. The next thing we do is the adaptive cabin. It's taking these same principles, it's loading up more learning modules here and using it to do things like personalize the setting of the seats, using it to turn on the preconditioning of your cabin. And probably the biggest goal here is to stop the ping pong game, which is played between couples driving in a car, with one person turning up the aircon and one person turning it down. So we sit at the layer between the HMI, between the interaction that goes in from the driver and the responsiveness of the systems to make systems work in the way that people want them to work and expect them to. Finally is the chassis. And imagine that you have all these different CloudMade modules loaded up within the car. And they've been observing where you drive over the past few weeks and how you drive. So the predictive routes module knows that you're going to drive along this road. Now, the predictive driver behavior module knows that under this particular context, you're going to drive in quite a sporty way. So as you approach the first corner, autonomy is turned to minimum, so that if you happen to clip the center line, the lane departure warning doesn't go off. Your steering is turned to sporty, so it's stiffened up to really make you enjoy the drive. The seats become active, and the seats actually close up around you and hold you in place as the air bladders that are in the seating is actuated and filled with air to hold you in place. And the suspension is kept stiff to give you a comfortable ride. All of this is possible because of the way we're able to wire the different learning modules together to build increasingly complex use cases based on these predictions. So that's the user experience that we're enabling. And everything that I'm showing you is based on projects that are either being built into pre-development or development phases with OEMs right now. So this is all stuff that is being done by CloudMade. This is not roadmap or ideas that are being shown. This is projects that are being built. One, of course, of the big problems that we had to address is the fact that cars have very unique and different electronics architectures. This has caused a problem for a lot of companies who've tried to come into automotive from outside, because an app that works in a typical operating system, mobile or desktop context, it can work to a certain extent within the car infrastructure, but you quickly hit problems when you try to scale it. So what CloudMade has done is design everything we've done from the ground up for automotive. We have a very strong principle of working very closely with customers on co-development. So every single product feature that we build in CloudMade is built with a customer. We don't build anything speculatively. We build things to real customer requirements. And that kind of makes sense because we're software experts. We're not chassis experts. We're not seating experts. So we deal with this. And any of you here who work in car electronics will, find these kind of things discomfortingly familiar, that we deal with the very complex internal electronic systems, multiple different buses that are often not talking to each other. They've been deliberately architected so the data from the infotainment system is kept separate from the data from the ADAS systems and so on. And there's no single abstraction point within these kind of architectures. There's often no one place you can go to ask for information from the different systems. There's no one insertion point for software which is based on collecting data and building predictions. So CloudMade integrates into this stack. We work with a range of different partners to do this. We typically sit underneath the application layer, and we have a range of different APIs that OEMs use to build upon. But of course, what I just showed you is just one example of our system. And what we learned very quickly is that one size doesn't fit all in automotive. You can't simply have one SDK which is downloadable for a website and expect it to work. So at CloudMade, we're able to build into a number of different car systems. So we typically will deploy in a range of modes. The first is natively onto an infotainment system, onto Linux or QNX. But we are also increasingly installing into different ECUs, into the TCU itself, where, of course, we have very good overview of all the traffic flowing into the car, onto gateways, onto body control modules, and so on. And this really leverages the ability of our system to build learning in the cloud. Because we're able to sit onto two different buses that have two different sources of data, plus a user's smartphone that has another source of data. We're able to pull that up into the cloud and use that to create a single driver profile from. So this is a system that we have architected from scratch to work within the very specific context that you see within here, within the typical setup. Typically, one of the big challenges, and this has been talked about in several talks today, one of the things that's very difficult when building adaptive user interfaces is how you don't freak out or surprise the driver. And this is something that we've spent a lot of time on in CloudMade, and this is partially, the way to address this problem is partially coming from software and partially coming from good quality learning and predictions. But it mainly comes from process. It mainly comes from the fact that we've spent 5 years figuring out how to make teams of designers, data scientists, and developers work very well together as a single unit. And there's no way to fast-track that. There's no way to have a data scientist and an engineer suddenly come up with an algorithm in isolation that is going to delight a user that they've never met, that they've never done a focus group with, and they've never done a drive test with. So we've built processes which allow us in the research to advanced engineering phase to do agile development, to do very, very rapid sets of focus groups and user testing, and use the data we collect on a daily basis from real drive tests to influence the way learning and prediction algorithms work. So a typical project for us, runs over a number of different months, starts from an ideation phase, goes very quickly through focus groups into paper prototyping. We then get to a point of building the software. We today build on a whole range of different car platforms, from the Nvidia Drive CX units all the way through to rapid prototyping things on smartphones, back through to the other end of the spectrum, building onto production and near production units at OEMs like the one that you see here. Built into this is the principle of being able to do very rigorous analytics on top of all of the predictions and learning that we're doing. One of the key software capabilities we built to do this is the ability for each one of our different prediction modules to be tuned to be use case specific. So imagine this same predictive navigation use case, which is a nice, easy use case to conceptualize. We have exactly the same module using exactly the same data feeding these two use cases. One is when you get in your car can give you 3 best predictions of where you're going next. The other is that when you're sitting in your office in a meeting, your mobile phone buzzes and tells you that there's really bad traffic on the road and you have to leave very soon to get to the office. Now that's the same data, it's the same learning algorithms, the same prediction module that's being used. But our system is able to change the certainty levels for this. So the user on the left, the My Car app on the left, that will only receive this message if it's very certain about it. The prediction threshold can be pushed right up to 98, 99%. So it only receives a prediction when it's certain. So very use case specific. The example on the other side of the screen, the car interface saying Golden Gym, with there you have a little bit more leeway. You would rather have more results coming up and risk that maybe I'm not going to the gym, I'm going to the restaurant. So the way to deliver predictive interfaces that people love is through a lot of iterations, a lot of time spent between designers, developers, and data scientists figuring out how to optimize and tweak things. It's also about having a capability within the software to be able to tune these certainty levels so the predictions that are delivered are fit for the context. All of this is run through a very rigorous analytical proof point framework. This is really where doing learning in the cloud pays off big time, because we're able to run extensive tests of the learning system from the cloud. If all of the learning is happening in the car, validation becomes quite difficult. When you have all of the data up in the cloud, validation is very, very easy. And we're able to, after production, we are able to come in and see when the car is in production how algorithms are performing. We're able to change and tune them. And we fully expect we will have to, because we see very different behavioral habits in different regions. And obviously, doing pre-production validation in every single region a car is going to go into is not feasible. So we try and pick a representative set of regions, some in North America, some Europe, Asia, Africa, and so on, because we know that when the car is in production, we can see the real data and very quickly make changes to the algorithms up in the cloud without having to change the software in the car, whilst all the time having all of the predictions that go on happen solidly within the car, not reliant on a network connection. So the final problem that I talked about, when the technical problems are solved, usually it's the biggest problems that are left on the table. And clearly shifting business models is a big theme within the industry. It's unclear exactly who will remain in command of the user in the next 5 to 10 years. For CloudMade, ultimately, what our solution does is allow OEMs to build lifelong relationships with their customers. So imagine a particular OEM has this driver, Max, who at 18 years old has his first experience driving one of the OEM's cars. And the video is not quite loading, but I'll narrate it. So you can imagine Max, maybe like me, driving a Renault Clio. he starts to get the taste of this particular OEM's product. Later, 4 years later, at 22 years old, Max still doesn't own a car. He's car sharing, he's renting. But most of the time, he comes back to that same OEM. So if this was me, I'd be looking for Renault cars or Nissan cars or Dacia cars because I had such a good experience that first time round. All the time while the profile of Max is getting richer and richer up in the cloud, allowing the car to customize the interfaces that Max is seeing to a greater and greater degree. At 27 years old, Max may decide to purchase his first car. And his purchasing decision has already been made because this very rich profile that's been created in the cloud, Max knows he only gets that if he stays loyal to the OEM. Just in the same way you can't take your Apple profile and move it to an Android phone. You can't take your Google profile and move it to an Apple phone. That's what CloudMade's customers are doing with our solution. They're using it to build this path dependency to reward drivers for staying part of their ecosystem. So as Max progresses through his driving career, he gets treated to better and better experiences. You know, as I talked about, this is not just impacting things that they see in the car, but it's what they feel in the car. It's the way the chassis performs, the way the seating is set up, the way the lighting in the car works around a driver like Max. And the goal here is to keep drivers loyal to the particular brand throughout their whole lifetime. So the way that OEMs and Tier 1s work with CloudMade's solutions today is through a range of 14 different solution sets. There's no way I'm going to have time to go into all of these today, but you can get in touch and we can talk about them more. It's been great to chat. CloudMade is around about 45 people. We have an office here in Menlo Park. We have all of our development and design based in Europe. There are a number of us based out here in the Valley. There are more of us in Europe. If you're an OEM or a Tier 1 interested in personalization who are facing some of these problems I talked about, we'd love to talk to you. So thanks for listening.